Good evening. I'm very happy to be here tonight for you with a special Mars Opposition TeleTube event. My name is Dr. Elena Hyde, and I'm here tonight with an absolutely wonderful crew. As they say, all across the skies of Earth, very few objects excite the imagination quite like our dusky neighbor Mars. And just to put up a very old quote today for our special Mars Opposition TeleTube, I'll just go ahead and quote a little bit from Kepler. But who shall dwell in these worlds if they be inhabited? Um, are we or they lords of the world? And how are all things made for man? So, since the days of Kepler, that's a quote from the Anatomy of the Melancholy, the planet Mars, and indeed many other objects in the sky, but for tonight, we'll go with Mars, have really excited the imagination. So, we're going to discuss a bit about our rusty neighbor. And just as a little getting started here tonight, we have not just myself, but also your main presenters, Gagan, Aria, Kat, and Noah. And of course, I'll just give a little shout out here to Obata and Anna, who have tried to open up the 1 meter telescope tonight, but unfortunately are getting rained on. Um, so it's just a little bit of a welcome and getting started to tonight's TeleTube presentation. This is, in fact, our regular TeleTube broadcast time. It's just a little bit of a special event with Mars Opposition for this year. And these teletubes are presented every Wednesday night at 7:30 to 8:30, and they're all about creating online astronomy and astrophysics programs written and presented by our students, faculty, alumni, and friends of York University. So this event has been running for several days here over October at the Alan Carswell Observatory so that we have as many chances of showing you amazing views of Mars through our 1 meter telescope. And of course, just as a little reminder, if somehow you don't get quite enough astronomy today, these broadcasts do occur every Wednesday night at 7:30 on this channel live, and they're recorded, so you can also catch them in our playlists if you miss a few. If you do have any questions or comments you aren't able to get to in chat, you can always email us at observe@yorku.ca, and you can connect with us on Twitter or Instagram with the handle of @York Observatory and on Facebook at Alan I. Carswell OBS. All right, just to go ahead and actually get started here, I'm going to give a little bit of an introduction because this has been an interesting Mars opposition. It is, in fact, one of the best, as you'll hear later on today from our crew. And because we have been running for several days, I actually have a few views I can show you from the 1 meter telescope of kind of a little, if you will, a bit of a recap of our events so far, and some of the images that we've managed to capture. So one of the things you're going to hear about tonight is just how interesting and how unusual a Mars opposition like this is. So I'm actually going to start off tonight just by giving a little bit of a recap of why this is so intriguing and important to us. So when you hear about Mars being more and more visible and brighter in the sky, there was a recent astronomy picture of the day which really illustrated this. And you're going to hear more about the orbits later, so I won't spoil too much. But why we get so excited about these views of Mars is because it really is so much better through telescopes, and you can see more features. You can watch the features change from night to night or hour to hour. And this was an astronomy picture of the day made earlier this year, where somebody had tracked the appearance of Mars through a telescope as it came closer and closer to opposition. So you can really see that Mars has, some really amazing views, and because we can kind of watch it changing in real time, that means over the days that we've seen Mars, we actually have a little bit of features we can show you already. So this is a little bit of our greatest hits, astronomy greatest hits, that is. And these are some views that we captured previously through the 1 meter telescope of Mars through our eyepiece cam. So some of these are a little bit blurry, mostly due to seeing and the clouds in the atmosphere. Unfortunately, tonight it is in fact raining at the telescope right now, so we cannot open. But you can see that depending on the amount of cloud, we can get a clearer image of Mars's surface and a clearer image of those surface features. But they're obviously not all the same face of Mars. So Mars does rotate just like Earth does, and Mars has a day that's actually a very similar length to Earth's day. So as we watch hour to hour, Mars will appear to rotate to us as well. So we can actually see these features moving across the planet. So this is October 5th on the left, October 11th in the middle, and October 13th, just yesterday, is shown on the right here. Um, and this was actually one of the ones we did record as well on YouTube. So if you want to see it wobbling about in real time, that's also available later. The features that we see in these different images are things like the albedo features, the light and dark regions. You can see Syrtis Major in the first image very clearly, but on the 11th it has rotated out of view. And if we watch this over several days, this makes sense, but it is worth noting that Mars, like Earth, it rotates, not just a little bit, but it rotates a substantial amount so that it can go all the way around almost every 24 hours or 23 hours in the case of Mars. Um, so over the course of an hour, this was taken yesterday, and we went ahead and captured the screen at the beginning of the show and the end of the show. So over the course of about an hour and some change, the features did shift just a little bit. Unfortunately, our seeing isn't great here. So one way you can check this is actually to use something called the Mars Profiler. So I'm just giving, of course, I'm sure this is not a paid promotion by any means, but this is the Sky and Telescope Mars Profiler, which allows you to show what face of Mars is visible during what time of day. So I can, of course, go ahead and I'll just shift this a little bit here so that I can grab it. And the Mars Profiler will allow me to track the position of different features. So right now on Mars, if it wasn't raining on Earth, we would be seeing a little bit of those same features we saw yesterday, but they would be shifted. So these two dark albedo features, Mare Serenum and Mare Cimmerium, they're actually just above what you'll hear later for Olympus Mons. So this region in the middle called Amazonas, this is an equatorial region. And you can see that the largest mountains on Mars are located around here. So we were actually able to kind of see where the mountains would be. We don't have the high enough resolution to actually see them, or unfortunately to make out the little corner of the polar cap that's currently available to us. But one nice thing on here is that I can actually change and move forward an hour. And so every hour, what you're seeing now is just a shift, every hour that goes forward, I actually get a slightly different view of Mars. And so if you were able to watch this all night, and it is up all night, you would actually get to see the face of Mars go by, which is really, really cool. So we get to see Mars and we get to see the features on Mars with this opposition. And it is very, very exciting for all of us here tonight. So we're very pleased to be able to just kind of present it to you, even though it is, of course, raining in Toronto right now. So we won't be doing live images, but we can show you exactly what it looked like last night. So just to go ahead and hopefully whet everyone's appetite for learning a bit more about Mars, I'll go ahead and hand over to our wonderful crew and remind everyone that if you have questions during the show, please feel free to ask them in chat live on YouTube, and we'll answer as many of them as we can. So just as a little bit of getting started. So Noah, I believe you're up first.
Yes, I am. Thank you, Dr. Hyde. So before we dive into this exciting event, let's discuss a bit about Mars itself. Mars, although we look to it as a potential second home, is actually very different from Earth. It has a day length of 41 minutes and a year around 322 days longer than our own, not to mention a gravity that is only 38% of ours, a gravitational acceleration of 3.7 meters per second squared in comparison to our 9.8 meters per second squared. It's also a fair bit smaller than Earth. Earth is 10 times more massive than our next door neighbor, and Earth's equatorial radius is nearly double Mars's. Furthermore, in contrast to our mainly nitrogen, oxygen, and argon atmosphere, Mars's atmosphere consists mostly of carbon dioxide, noble gases, nitrogen, and gaseous water. Speaking of elements, interestingly enough, heavy hydrogen, known as deuterium, is actually more prevalent on Mars than ordinary hydrogen. Just to make things even more abstract, the temperature on Mars has a large range, from a whopping negative 153 degrees Celsius to a moderate 20 degrees Celsius, and it can actually differ immensely by only a few mere feet of altitude, due to the extremely thin atmosphere lacking the ability to maintain heat above the planet. Mars is the next planet towards the Sun, the fourth out from the Sun, and as I just alluded to, it is one of the hotspots of space exploration in the solar system so far. In fact, 3 missions are currently on their way there: the United Arab Emirates' HOPE probe, China's Tianwen-1, and NASA's Perseverance rover and Ingenuity helicopter. This planet is like our own, a rocky planet, and its terrain is very rocky, as you will later learn. Its core is composed of nickel, iron, and sulfur, 1,240 to 1,888 miles beneath a 10 to 50 kilometer deep potassium, aluminum, calcium, magnesium, and iron crust. Mars is also widely known for its dust storms, periods of time when red dust is kicked up and swirled around the planet due to the constant presence of dust on and above the ground. These storms sometimes grow so enormous that they envelop the entire planet at once. Now, on to the main purpose of this event: Mars's opposition. So, what is Mars's opposition? It's an event where the Sun and Mars are on either side of the Earth, such that as soon as the Sun rises in the east, Mars will set in the west. Since these two events happen simultaneously, we dub it opposition, as they directly oppose one another. Normally, opposition occurs once every 2 or so years, and every 15 to 17 years, it occurs within a few weeks of Mars's perihelion, or closest approach to the Sun. When this happens, Mars is closest not only to the Sun, but to us on Earth as well. This ensures spectacular viewing. In fact, Mars's closest approach to Earth for this opposition was last Tuesday, October 6th. A fun fact about this is that due to the close proximity of our planet and Mars, space agencies actually tend to send their spacecraft to Mars around oppositions to minimize the distance and time of travel. All right, so going back to perihelic oppositions, Mars's orbit is actually prone to elongation, so it's gradually becoming closer to the Sun during its perihelion, enabling Mars's oppositions at perihelion to subsequently become closer and closer to Earth. Along these same lines, did you know that at some oppositions, Earth and Mars are closer than at others due to the slight tilts between Mars and Earth's orbital axes, not to mention the gravity of various planets and bodies around us? All right, so now you know about Mars's opposition, but you may be wondering why this year's opposition is such a big deal. It's important to mention that opposition is extremely unique and magnificent due to the light that Mars reflects during this time, light that can be seen here from Earth. Mars, to the human's eye, will appear more brilliant than at any other point throughout this event, as we'll be able to see a brighter planet because of this, even more so than when Mars is closest. It'll be around a magnitude of negative 2.7, brighter than Jupiter and even Sirius. When this happens, the amount of detail we'll be able to view of Mars, the features you will hear about a little later, will be ever more visible to us, not to mention that we were able to see it in light hours. Not only that, but this was the closest opposition for 15 years, with Mars 0.41 astronomical units away, the closest opposition until 2031, and the best since 2003. In fact, in 2003, Mars was actually the closest it had been in nearly 60,000 years. Another exciting feature of this Mars opposition is that, as I mentioned, it is very bright, and the features on the surface are easier to see. Last night, the brightness of Mars increased substantially, with a visible magnitude between -2.5 and -2.7. Currently, it rises around 7:30 p.m., and if you're near Toronto looking towards the lake, it will be on your left to the east. It's in the east right now, close to Uranus, and it can be found in the constellation Pisces. Another major milestone last week was that, on October 3rd, Mars was also only 1.1 degrees from a virtually full moon. This was the last closest conjunction of Mars and the moon for 2020. So how can you see Mars? To find a planet like Mars, the first thing is to remember that planets don't twinkle. The light from planets only travels a few million kilometers or miles instead of many light years. There is also a great deal more of it, so it passes easily through our atmosphere. Point sources of light, such as stars, are very prone to distortion, so they are not nearly as steady. So unlike a star, the planet will not twinkle as it shines. The times to view Mars will vary depending on where you are observing from. If you're near the general Toronto area in North America and looking east at about 7 p.m., Mars should have just risen. By around 8 p.m., it should be sitting about 15 degrees above the horizon. An easy way to estimate degrees in the sky is to realize that 90 degrees is directly above your head, also sometimes called the zenith. And then you can use your arm to gauge how far from the horizon you should look. Don't worry if it seems like a challenge, because Mars will be very bright and very red, so it should be very easy to make out. By around 1 a.m., Mars should be due south from downtown Toronto, and by 6:30 a.m., it will be beginning to set in the west as the sunrise brightens the opposite horizon, hence the term opposition, as I mentioned earlier. So go take a look outside tonight and over the next couple of days and enjoy the incredible view. Next, Gagan will be sharing you a bit about features on Mars.
Thank you, Noah. Now that you know more about Mars and its opposition, we'd like to go through a bunch of cool geographic features on Mars that you might be able to recognize in some telescope images. Mars has a super interesting terrain with lots of easily distinguishable landforms, and since Mars rotates, over the course of a few days of observing, you can see a lot of different features. Mars also has clouds similar to Earth, which you can easily see as a streaky white spot, such as in these images below, and you'll hear more about some special clouds on Mars a little later. First up is one of my favorite features on Mars, Valles Marineris. Valles Marineris, Latin for the Mariner Valleys, and named after the Mariner 9 orbiter credited for the discovery, is a massive canyon formation near Mars' equator. The canyon system is one of the largest canyon systems in the solar system and covers an area on Mars' surface almost the size of the United States. The valleys stretch for over 4,000 kilometers long, 200 kilometers wide, and about 8 kilometers deep. To compare, the Grand Canyon's maximum depth is only about 1.8 kilometers. There are several theories on how it formed, including plate tectonics or volcanic activity during the early days of Mars formation, followed by landslides and further volcanic activity to widen and deepen the trench. The image on the left of the slide is a mosaic image compiled from the Viking 1 orbiter mission and shows just how much of Mars' surface the canyon covers. On the top right is a more detailed view of Valles Marineris, also taken by Viking 1, and the bottom right image shows a topographic view. Mars' polar regions are also super interesting areas. The North Pole, Planum Boreum, is home to a permanent water ice cap and a seasonal dry carbon dioxide ice cap, which sits on top of the water during Martian winters. The water ice cap can reach up to 3 kilometers in depth at some points. The North Pole also has another canyon, more comparable in size to the Grand Canyon, called Chasma Boreal. The image on the left shows the ice cap and also dust storms around Planum Boreum, taken by the Mars Global Surveyor. The image on the right is a more detailed image of the North Pole water ice cap. Mars' South Pole, Planum Australe, has also some interesting features. There is a permanent water and carbon dioxide ice cap approximately 3 kilometers thick and recent observations by the European Space Agency's Mars Express orbiter indicate the presence of saltwater lakes under the southern ice cap. I'll go into a little more detail about their discovery. In 2018, an Italian team of researchers announced evidence of saltwater beneath the southern polar caps of Mars. The radar sounder of the ESA Mars Express orbiter had detected unusually bright reflective patches below the ice. This, the researchers argued, could be a lake of liquid water, 12 miles across, that melted from the ice cap and was trapped beneath it, over a kilometer beneath the surface. On Earth, similar lakes form beneath glaciers, where heat from the ground and the pressure of the glacier above melt some of its ice. And although Mars is too cold for pure water to remain in liquid form below its glaciers, it could do so if it were extremely salty with a much lower freezing point. This briny mixture might be filled with salts called perchlorates, dissolved from rocks. But it wasn't a slam dunk case. Mars is not very geologically active, and it's not clear whether the planet's interior can supply the amount of heat to create a lake that size. Now, scientists are back with a new study, published September 28 in Nature Astronomy, that they say bolsters their argument. They use data from the Mars Express radar sounder called MARSIS, or Mars Advanced Radar for Subsurface and Ionospheric Sounding, and analyzed a dataset of 134 radar profiles compared to 29 in their previous study. They also bought a new approach, adapting radar techniques used by satellites orbiting Earth to image buried geological features. Their analysis looks not just at how bright an area is, but other metrics as well, such as how the signal strength varies, indicating how smooth the reflecting surface is. Previously, this method has found subglacial lakes in our own Canadian Arctic. The interpretation that best reconciles all the available evidence is that the high-intensity reflections from Mars are coming from extended pools of liquid water. There's not enough heat at these depths to melt the ice, so scientists believe the liquid water must contain high concentrations of dissolved salts. These chemical salts, different to the stuff we sprinkle on our chips, can significantly lower water's freezing point. In fact, recent experiments have shown that water with dissolved salts of magnesium and calcium perchlorate, a chemical compound containing chlorine bound to 4 oxygens, can remain liquid at temperatures of negative 123 degrees Celsius. Now back to more surface features. To the west of Aurora Sinus is the eye of Mars, the central feature being dark Solis Laxus. It was also commonly referred to as the oculus, the Latin word for eye, because the light is focused in the surrounding area, closely resembling a pupil. Pictured to the left is the plane on which the Solis Laxus resides, and to the left is a Hubble captured image of the eye, located on the lower right of this perspective of Mars. As well, the size and shape of the Solis Laxus varies based on dust storm occurrences, also analogous to the widening and narrowing of one's pupil. The immense Valles Marineris Canyon lies northeast of Solis Laxus. Between the southern boundary of Syrtis Major and the southern polar ice cap lies the Hellas Basin. This 2,300 kilometer diameter basin is one of the largest impact craters in the solar system. The depression into Mars, measured at approximately 8 kilometers deep, noted as being the lowest point on the surface of the planet, indicated on the picture to the left as per the topology of this area. The depressions are illustrated in more purple tones, while the higher peaks are represented in red. Hellas can sometimes appear bright due to the clouds that form in the basin and was likely formed during early Mars history. Another one of my favorite features on Mars, and probably the most popular one, is Olympus Mons. Olympus Mons is an extremely large shield volcano and the tallest mountain in the solar system. Its height from base level is 21 kilometers, making it 2.5 times the height of Mount Everest. It encompasses an area roughly the size of the state of Arizona and is easily visible from the Earth. There are several reasons why this volcano is much larger than anything on our planet. The most obvious answer is the lack of gravity allowing structures to keep growing beyond their collapse height. Another reason is due to the lack of tectonic plates on Mars. The reason volcanoes grow is due to the fact that hot magma is pouring from the inner parts of the planet. On Earth, these plumes move relative to the plates, causing a more scattered mountain formation, like the chains of Hawaii. On Mars, these plumes keep spewing magma in the same spot, which allows volcanoes like Olympus Mons to grow so tall and wide. Next, Kat will be telling you about some fun facts about Mars and also some of the rocks on Mars' surface.
Thanks, Gagan. So, I will be beginning with some fun facts about Mars. So, Mars is a genuinely really interesting planet, and not only because it could be our future home. Did you know that its red color due to oxidized iron reminded people of blood, hence it being the namesake of Mars, the Roman god of war? Not only that, but the god's varying temper was brought to mind when they saw the planet's dramatic variance in brightness over time due to its distance from Earth. Mars, like many planets in our solar system, has natural satellites orbiting it. Phobos and Deimos are Mars's two moons, named for the sons of the Roman god Mars, Greek equivalent Ares. They were found within a span of 7 days by Asaph Hall, Deimos the night after he nearly quit his search. These moons are suspected to have been asteroids captured by Mars's gravity, both with little mass, small enough to not have a large gravitational force to round off the moons. Phobos is actually falling towards Mars, gradually, of course, and will either break into pieces or collide with its host planet in 50 million years. Once this occurs, Mars may gather the particles and form its own ring, similar to other planets nearby, the most obvious of which is Saturn. One other interesting fact about Mars is that just less than half of humanity's missions to the red planet have actually been successful. However, they have grown increasingly effective and successful, proving the importance of patience, dedication, and yes, perseverance. In the early space age, scientists thought that Mars was just like the moon. During all flyby missions, all spacecraft coincidentally imaged the craters of Mars, which led to the belief that Mars had a similar environment to the moon. However, further research proved that there were more dormant volcanoes that sat on the surface, changing our view of the planet forever. There are pieces of Mars on Earth. Over many years, pieces of the Martian surface has landed on Earth, allowing scientists to study Mars without having to set foot on it. The three most common types found are shergotite, knacklight, and chasnigite. Shergotite is a volcanic rock rich with magnesium and iron. Knacklight is also a volcanic rock, but generally formed a lot older than shergotite and is rich with the mineral augite. Chasnigite, made almost exclusively of the mineral olivine, contains noble gases different from the composition of the Martian atmosphere, which suggests that they are formed in the mantle. Mars was previously believed to have held intelligent life. Well, we still would like to believe it did, and does currently, but we just don't have as much evidence. The Italian astronomer Giovanni Schiaparelli had thought that he discovered canals on the Martian surface, but was later proved from when what he thought were canals were actually channels. The difference is that canals refer to artificially made structures, while channels were simply a part of the natural landscape. As mentioned earlier, Mars has many interesting features. Some include the vast valleys and canyons, indicating the fact that liquid water once ran through them. Despite it currently being a dry wasteland, we have significant evidence that Mars has plenty of liquid water that has now been sublimated or frozen under the surface. The most obvious point is the polar ice caps, as we all know, on the poles of Mars. These ice caps are composed of both dry ice and water ice. Some previous missions to Mars were also able to detect snow. Yes, snow in the upper regions of the atmosphere. Although it isn't anything like the snow here in Toronto, it is still a very interesting and significant discovery. In addition to all of this, ice is easily found in many regions buried under the Martian sand. This could be very useful to future astronauts who are not going to be carrying their own water supply. In conclusion, there is plenty of water on Mars. Mars has huge dust storms that can cover the entire planet for several months. A theory as to why this occurs is because airborne dust particles will absorb heat from the sun, which will create pockets of warm air. That warm air will move towards colder regions, and in the process of doing so, generate winds. These winds kick up more dust particles, and the cycle continues. Mars's tilt swings wildly over time, unlike Earth's, which stays at an average of 23.5 degrees. The reason is because Mars doesn't have a large enough moon to stabilize it, unlike our good pal Moon. Mars currently has no magnetic field. However, there are regions on Mars that have at least 10 times the magnitude of any magnetic field measured on Earth, which may hint at the possibility of an ancient magnetic field. Blueberries were recently found on Mars. Well, not the blueberries we know, but instead iron-rich spheres found near the landing site of NASA's Opportunity rover. They indicate that Mars was once incredibly wet, flowing with a lot of liquid water. Why are rocks like the Martian blueberries so interesting? It's all about their composition. The so-called blueberries are actually hematite spheres. Hematite is a mineral that is often formed in a wet and water-rich environment. So if we can understand hematite here on Earth, we might expect that on Mars, water would have been needed in order to make these minerals appear. So hematite has a reddish to black color because of its iron and oxygen, as you might have heard before. Mars gets its overall red color from all the iron in the surface rocks, including hematite. Mars rocks have many various types, but one of the most common is due to ancient volcanoes. That's right, we have lava rocks. On Mars, lava rocks interact with other environmental features like water and wind to form interesting types of rocks and minerals to explore. In particular, mineral deposits formed by lava-heated water containing salts, sedimentary rocks deposited from volcanoes or erosion, igneous, which is your typical lava rock cooled down, cooled solid lava, and finally, metamorphic, which is sedimentary or igneous rock transformed by high pressure or heat, usually from volcanic activity. And here I take it on to Aria, who will talk more about Mars rocks.
A special shout out to igneous rock. These jag-hard rocks are produced when lava rocks, as discussed previously, cool down. They change depending on the lava or magma they were formed from. Depending on their origins, they will have different amounts of things like quartz and type of feldspar crystals. Sedimentary rocks are the ones that we are quite familiar with here on Earth, as they are rocks that are eroded by environment, by wind or water, or deposited sometimes along river channels. Sedimentary rocks on Mars include things like sandstone and shale. If you erode sandstone, you tend to get sand both on Earth and Mars. How about metamorphic rock? Metamorphic rocks are arguably the coolest name, and the type or mineralogy of rock is determined by the temperature and the pressure used against it. For example, for the presence of volcano igneous rock, we can tell what type of volcano activity Mars used to have. Mars has an interesting surface. Part of it appears very cratered and pockmarked, while ones are blue, as blue in this picture, seems to have less craters. In solar system, the more crater a surface has, the older it's thought to be. It is because the activity like water, wind, other geology moves and pushes surfaces, destroying craters. At some point in the past, Mars had enough water on its surface to form a lake, erasing many craters in one area. Although we cannot see the lake anymore, we can see where it used to be by looking for the least cratered area. Water on Mars is a hot topic, especially with the lakes that have just been discovered underneath the poles with radar. However, it should not be very surprising. This map shows hydrogen within the Mars surface area. The hydrogen abundance is linked to water. As you can see, it is concentrated at the poles. This map was done by neutron spectrometer aboard Mars Odyssey between 2002 and 2003. So as you can see, we have had evidence of water for a while. A famous face on Mars always conjures up mystery. When it was first imaged, the lighting was such that the shadow seemed to form a face. Although the features has since made it into sci-fi movies, unfortunately, it is just a projection effect. High-resolution image shown on the left give a clearer picture of what the area looks like. It's worth nothing that just the resurfacing that helped shape this future on Mars would have required many of geological processes talked about earlier. It may not really be a phase, but it does indicate that Mars is neither dead nor dry. Why is Mars red? A question that has been asked through the ages. Currently, scientists think that the red color is due to oxidation of iron, also known as rust. This rusting would have started a long time ago, early in Mars history when water flowed on the surface. The oxygen in the water and the iron combined to create rust, eventually leading to the overall red surface we see today. New studies have shown that quartz magnetite can also create what is called red hematite, which is also added to a bright color and could have been created more recently. With the help of Mars Express orbiter and the visual monitoring camera, astronomers at the European Space Agency have spotted the return of a mysterious cloud on a red planet on July 30th, 2020. The long narrow cloud of water ice was observed on the leeward side of Arcia Mons, a large volcano near Mars equator. Mars Express captures images of the returning features in mid-July. This elongated cloud forms every Martian year during this season around the southern solstice. A repeat of 80 years, 80 days, or even more, following a rapid daily cycle. Astronomer George Hernandez Bernal said in an ESA news release, scientists on the project recently named the planet's most prominent cloud as Arciamon's elongated cloud, or AMEC, or in other words, AMEC. Though Mars' atmosphere is much thinner than Earth's, the red planet regularly hosts cloud formations. Studying Martian clouds can help scientists better understand Mars' climate and seasonal weather patterns. Like Earth, Mars has an equinox and solstice periods, but due to Mars' larger tilt, the seasons are more extreme. Early in the morning, during the southern solstice, long wispy cloud like AMEC often forms, growing quickly before disappearing by afternoon. Most orbiters snap photos of Mars in the afternoon, but Mars Express does its observing in the morning. When southern clouds are more likely to appear, luckily for the Mars Express, it is the highly elliptical orbit of the spacecraft, coupled with a wide field of view of VMC instrument, lets us take a picture covering a wide area of the planet in the early morning. Mars Express has previously used a near-infrared mapping spectrometer, Omega, to image EMEC in September, June, and July of 2018.
Thanks very much for that, Aria. And I'll just go ahead and go over to our a little bit of an outro-ish event here. We do actually have quite a Mars connection with the observatory, and I just thought, since this is our official Mars TeleTube event, it would behoove us to note that the Ellen I. Carswell name is in fact on Mars as well. So it's not just Alan I. Carswell Observatory, but also there was a person, or there is a person, I should say, Alan I. Carswell, who we are named for. So I suppose we're the namesake, but it all goes back to Mars in the end. So how does this all work? Well, on September 14th, 2017, Professor Emeritus Alan I. Carswell donated $500,000, which was matched by York University's Faculty of Science, allowing us to purchase a new 1 meter telescope, which we have been using all kinds of different ways to show Mars throughout this event. Of course, provided it isn't raining like it is today. So the observatory was renamed in honor of this donation in August 2019. The telescope was installed, so fairly recently. Well, our Mars connection comes in with that name because Alan I. Carswell also served as the co-investigator of the Mad Dog LiDAR instrument, which was accepted by NASA for inclusion in the 2003 Mars lander mission. It was actually renamed a couple times after that, but we'll go ahead and keep calling it Mad Dog because that's a pretty good name for an instrument. So the mission was aborted But the LiDAR instrument development work continued as a part of NASA's Matador program, and it actually led to an invitation for LNI Carswell to include Canadian LiDAR on the Phoenix mission. So the Phoenix mission was, absolutely wonderful mission, which we haven't quite got time to cover today. But the lander for that mission, NASA's 2007 mission, was heavily involved with sort of the Canadian science, and Dr. Carswell served as co-investigator, meteorology, and all around, I suppose, collaborator for that Phoenix mission, and he led the development of that first LiDAR, which was used for studies of the Martian atmosphere, which we have been talking a little bit about, white clouds and other things notwithstanding. So this LiDAR discovered the existence of snowfall on Mars, a previously unknown component of the Martian hydrological cycle. Very, very important for answering, I should say, riddles about, why the snow on the caps disappears and reappears. So the snowfall discovery was a major discovery, and in recognition of this huge contribution to the mission, Alan Carswell, along with his wife Helen and other members of the Phoenix team, had their names engraved on a silicon mini DVD inside this Phoenix spacecraft, which is on the surface of Mars right now. So in a way, our name is on Mars. Our name, I should say, the name of Alan Carswell is on Mars. And in a small way, our observatory is also on the red planet. So of course, it's no surprise to anyone that we're quite excited about this Mars opposition, and we hope that you have enjoyed the presentation. We will be taking questions in chat for the next few minutes, and of course, I'll go ahead and we'll do our questions in chat like we regularly do for TeleTube, which means that we will chat with you live for about the next 20 to 30 minutes or so. So thanks for joining, everyone. You have been listening to the Alan I. Carswell Observatory's special Mars Opposition 2020 TeleTube broadcast. These broadcasts are presented by astronomy and astrophysics students, faculty, alumni, and friends of York University. And the slides for our show were put together by the York Observatory 2020 Mars crew members, Kat, Gagan, Stanley, Obata, and Noah. You have heard tonight Gagan, Aria, Kat, and Noah, and of course myself, Dr. Hyde. Thank you very much for joining us on this exciting occasion. Make sure to leave any comments or questions in the comments section of the video. If you missed the live chat, you can always connect with us on Twitter or Instagram with the handle, I should say, at York Observatory, and on Facebook at Alan I. Carswell Observatory. All of our programs are free, but if you'd like to make a donation, please see our website at observatory.info.yorku.ca. Thanks for tuning in. Clear skies and have a great night.